You guys ready for Q&A today? Let's see a show of hands. As usual, looking at problems and solutions. We'll first take a look. 2 questions this time. We'll read the conversations. That'll give us the title of the video based on the motherboard we're going to be looking at. And 1 question that is about the chipset, the other question about a motherboard with that chipset. And I think the 2 together will be more consistent for a more congruent message, to better understanding. Because if we just explain one without explaining the other, some of you may go, huh? So our goal is to keep it simple, make it work, and let's see what we're dealing with. I love looking at these motherboards. Answer 1 question, we get another question. Okay, scrolling down and zooming in, this is from Burgo Forever R. BuildOrBuy, can you please do a video on the ProArt Z490 10G from ASUS? Thank you. So that'll be the title of our video. The conversation. Hi, welcome. That's a distinct possibility. And then I asked, will this be used as a DAW or video rendering or both? Instead of offering, I should just ask and leave it open and see where you guys take it. Anyway, the response. Both, I really appreciate it. There is this and the ASUS Maximus 8 Z590 Hero with Thunderbolt 4, and I just watched your video of the Gigabyte Z590 Vision D. Thank you so much for what you do. Thank you, appreciate it. Here to help. And I find these motherboards absolutely fascinating. Anything else you can add to this? Which audio interface are you considering? What's your video editor of choice? What about your GPU of choice? Thank you for your comments. This helps us to make better videos. CPU the cheaper, 10850, NVIDIA RTX 3060, NVMe SATA for storage, Scarlett 2, DaVinci, or Adobe. Okay. Well, that alone was enough to say, okay, I'm going to talk to you about a solution, but I wasn't quite ready about a video until we got the next question on another video that kind of goes with this. So we get some synergy as we have some what, why, and how to understand resource allocations. Let's go to that question. And this is one of my favorites, where we talk about the Gigabyte AORUS Generation 4 AIC adapter comparison and simple install tutorial on the TRX40 Designare. Okay, this question is from Philippe. Does the Generation 4 adapter work with the Z490? My response, hi Philippe, welcome. Working on next video related. We'll include your question in that video. Relevant question, deserves an explanation. So the first thing we need to do in this what, why, and how to make it work, we're going to look at the chipset. We can answer that, but I still think it'll leave some people going, WTF. So I think the best thing to do to show this is, as we talk about the chipset, then relate that to a specific motherboard. Now, at one point with the first comment we had, I was kind of on the fence about doing this about 2 motherboards. However, since we had already looked at one motherboard, I don't want to rehash a motherboard as we've looked at resource allocations. But I love looking at another motherboard. And I got to interject because we're going to get to it. Have you ever wondered about how many chipsets there are? Have you ever wondered about how many motherboards there are? There are more motherboards than there are chipsets. And that's something that's relevant if you've ever heard me talk. When I always say, motherboard's the foundation of the computer, chipset's the foundation of the motherboard. I like to know the chipset because it tells me what's going on. Okay, as we look at a quad card, I always talk about 2 requirements. There's actually 3. I'm going to mention that 3rd one today. The requirement for a quad card, any of the quad cards that are from Gigabyte, ASUS, ASRock, all the major manufacturers, all those that are currently shipping require motherboard bifurcation. And I say that because we have to remember we looked at and talked about, based on a press release, a card that Gigabyte's coming out with based on the server platform that's going to support 8 drives. 8 drives on a 16-lane slot means it's got a Broadcom chip, it's got a PLX chip on it, it's the only way it can do the lane switching. So that is a different kind of card that requires bifurcation on the card. The kind of card we're talking about in this question is a card that requires bifurcation on the motherboard. So 3 requirements. Number 1, you got to have a 16-lane slot because you got 4 M.2 NVMe drives, and each one of those requires 4 lanes. 4 times 4 is 16. And as somebody else mentioned, I didn't understand what the deal was with the SATA ports, why I would lose them, and what happened to them when I explained in the last video about each SATA port requires 1 PCI Express lane, and those are through the chipset. So as we look at a quad card, first requirement, 16-lane slot. Second requirement, bifurcation in the BIOS. Okay, when we bifurcate in the BIOS, what are we doing? That's actually, as we talk about the different types of RAID, where there is a hybrid BIOS RAID, there is an operating system RAID, so you have a software RAID versus the hybrid BIOS RAID, which is a combination of hardware and software. Well, the third requirement for one of these cards that I don't ever mention, that I'm surprised somebody else has not, if you've ever seen the term SoC for System on Chip, that's talking about hardware RAID as it relates to RAID, which is a function within the CPU. What does that mean? Okay, there's two types of lanes, PCI Express lanes, that we have on a motherboard. We have CPU lanes and we have chipset lanes. All these quad cards are working from a lane that's on the CPU, hence System on a Chip CPU lanes. And CPU lanes is where we get the power of the workstation and high-end desktop, those platforms where a quad card is designed for those platforms. Now, to reiterate, ASUS has done the most of any vendor to enable that feature on lower-end chipsets. A lower-end chipset is anything below a high-end desktop. So if we go look at PC Part Picker and we look at chipsets and we look at motherboards, some information we can glean from that, and we can filter through it. Suffice to say, I like to look at chipsets because based on a chipset, it's easier than to look at a motherboard. And from the motherboard, then I can discern and determine about what the CPU is doing, because I like to do those. So I think the next thing we need to do now, next step, and for those that are asking what that might be, the motherboard that we're going to make this video about for the title, the ASUS ProArt Z490 Creator 10G. So some of what we're going to get into, because of the two questions that are a little bit different but still similar and are in the same vein, I want to get into some likes and dislikes about this board. Based on some things I said in the previous video, 10G is a really big deal. This motherboard has an I/O card included with it to enable 10 gigabit Ethernet. So whenever you hear me talk about RJ45 and I'm talking about 10 gigabit, 10 gigabit could either be RJ45 or it could, which is copper, or it could be fiber. And I'm specifically talking about RJ45 based on 10G, based on copper. So I want to emphasize that point because that's what we're looking at here. So as we look down and go through the features, this also has Thunderbolt 3. So as a candidate for that first question, I like to keep these sticking to facts, but some of this is based on my perception and my experience. So that influences that thought process. If we're talking about, now digital audio workstation is usually specifically about a DAW, and that's a very defined requirement. If somebody says they want to build a computer like we have now, and I have asked with a leading question, is this going to be for a DAW or is it going to be for video? And he said both. Well, a DAW can be two ways. A proprietary machine that's all it does, which is not about a high core count, but a low CPU core count, but with fast processors, then that's one way to go, because then you're talking about a musician. If you're not a musician and you're using that DAW to do also video work, then I want a machine that's more balanced for a purpose-built machine to do other things where I want more CPU cores because I'm going to do video rendering, but I still need the fast CPU cores. So those two kind of things, and that's kind of where we're at. I can see building this machine in either a rack mount or a regular case. The concern with the rack mount, of course, is about noise, but if it's in a rack mount, you're going to put it somewhere where it's not right at you. For example, I have noise right now that I can hear that I know about that does not bother me, but when we did the live meeting, because the way I had the fans set up where they cycled up and down, people were going, what is that noise? Freaking out. So I changed the path for the fans, which are on the video switch, to keep it cool, to just be always on. Thus, it sounds like a white noise. That same principle and concept can apply to an audio interface, because a digital audio interface is usually more specifically about the drivers to drive, say, like a keyboard. Not everybody is using a digital audio workstation for microphone inputs, although that's what you want. Those preamps for microphone inputs, you may not use them. Okay, so one direction we can go, Thunderbolt 3 or Thunderbolt 4. When you've got a pro audio interface and you've got to have Thunderbolt for whatever reason, I always say keep it simple. You want to keep that for native Thunderbolt support, which means Thunderbolt 3. If somebody says, I want Thunderbolt, and it's not specifically about a DAW for a keyboard or about the digital audio converters for the mic preamps, which also double as inputs for like a guitar, high impedance inputs, then I would say Thunderbolt 4 based on the technology. But if you're going to have a Thunderbolt interface and it's about audio, because a keyboard is the primary input device, or it could be some other type controller if it's not a keyboard, but you get my gist. Because I'm all about virtual instruments, and man, that's the one thing that can really sing, that can really deliver that data quickly when you call up an instrument, and those instruments are on M.2 NVMe drive or an array, which could be RAID. So let's go through the specs and see how those specs are allocated based on the CPU that we would select for this based on what he told us. So I want to go to PC Part Picker. We're going to come back to the motherboard, we're going to look at the manual, and we're going to go back and forth and see how some of these things fit together. And I hope what I'm telling you and what I'm showing you and what we're doing makes sense. While I'm here right quick, I'll look at support. I'm not looking at BIOS for the sake of what version or revision we're on. We're not that far along, and that's not the nature of the question. We're still in the processing phase of getting the machine built. So we have one manual, ProArt Z490 Creator 10G insert. We have a second manual for the installation manual for the CPU. We have a third manual for the user's manual right here. And there should be a BIOS. Yeah. So what we'll do is come back and take a look at the BIOS manual, which is kind of slim pickings for what we want, but more specifically we'll look at the user's manual. So now I want to go over to System Builder. I have pre-selected two components, the ASUS ProArt Z490 Creator 10G and an Intel i9 10850K processor. That's a 10-core processor. Okay, I want to point out at this point that's a 10-core processor. An 8-core processor is a laptop. I'm not interested in building a laptop. If we're going to use a laptop, then a laptop's a laptop. And laptops are coming online with more cores. However, this is 10 cores. If I'm building a new machine, I don't want to build a brand new old machine, even if I'm building a machine for strictly a DAW. The only other thing that would move me to build a machine of this caliber might be for motion capture. And that's another topic I've done a lot of research on. So I've never done it, but I have a lot of information that over time I'm going to share with you guys based on what I've done with research. If you're using motion capture for one motion capture suit, then you may want to use an individual computer for each suit. If you have multiple suits, because you're not capturing video, you're capturing points in time, you might want to think about something more powerful if you're going to run multiple suits. But however, one suit, one computer. Then building something like this kind of sort of makes sense. But if you want to do this for video, that's not enough CPU cores, because I still go by the Adobe After Effects MultiFrame Rendering CPU optimization formula, which is the most complete and the easiest formula to understand. Now, based on the GPU you've got of a 1060, I would recommend at least a 1070, but you didn't ask, you just told me what you're using. But at least it's an RTX, it's a 1060. You're trying to build an inexpensive machine. So with this, you're looking at 10 cores with this motherboard. Let's see how the resources play out. We're going to go take a look at the processor based on what Intel can tell us. And what I'm looking for right here is 10 cores, 20 threads, turbo frequency 5.3, base frequency at 3.7 gigahertz. And I want to know, let's see, we'll support 128 gigs of MEM, DDR4 2933, dual channel. So to get to dual channel, there will be 4 sticks. You should be able to use all of it. And onboard graphics, which is not that big a deal because you're going to use a separate GPU. And I'll address the Thunderbolt thing here in a minute. I've seen some questions about some of that, so we're going to have to get back in and pay some special attention about routing video through Thunderbolt. Came across one of the motherboards we looked at that I know it was there, and somebody asked about it, and I said, oh, well, let me double check. I triple checked, and that connector that was there is not there. So the only way on a motherboard that I don't want to get into in this video, but I'm going to check on this one, is to make sure that you can route video through the external GPU through Thunderbolt, because if I don't, someone's going to ask. So I want to try to keep this simple back, but I'll get to it. I just mentioned it while I'm here. 4K support, 60 Hertz, maximum resolution. Of course, that's video through the onboard GPU. I want to know PCI Express lanes, and here's what's important. First of all, this is, remember, the CPU. Okay, we support PCI Express 3.0. It doesn't support PCI Express 4.0. That means an M.2 NVMe drive could be a maximum of 3,500 megabytes per second on that drive. whatever drives you've got in the machine. Even if you were to put a quad card in this machine based on that chipset, based on that processor, we still got to look at the chipset and see how those resources are allocated. But right now we have one 16-lane slot, two 8-lane slots, plus 2x4. And the maximum number of PCI Express lanes, as it shows, is 16, which is kind of a bummer because you have one 16-lane slot. That's where the GPU is going to sit. So anything else, we're probably only going to have maybe 2 slots on this motherboard, which means that other slot is going to be, unless we have 2 8-lane slots because they share bandwidth, remember, 16 lanes. So if you were to put a quad card on this machine with that chipset, it's going to have to be in that top slot, which is 16 lanes. You have to forget the second slot exists, and we still have to look and see if the BIOS will allow bifurcation. Based on the motherboard, because it's ASUS, I think it does, maybe, but I got to check, got to double check. So it's 16 lanes. That means there's could be 2 slots, but the third slot will be the one through the chipset. And since you have to forget slot 2 exists, whether it does or not, then you have to decide. Remember, there's Thunderbolt on this motherboard. So how do you put 10 gigabit Ethernet? Because that requires a slot that requires 4 lanes. Yeah, that's kind of our conundrum. So when you're dealing with shared resources, you got to figure out how you're going to divvy all that stuff up. And the way a motherboard is designed based on implementation is different than the way the chipset may be designed or allocated. So it's always better not to look at a chipset based on what we've been seeing, based on the X570 and all these others, to not look at a chipset until we have some motherboards to balance that to see how the design is on the implementation. Design is one issue, implementation is another. And the implementation is where we get the gotchas, the coulda, shoulda, wouldas, that I wish I'd have known beforehand. That's what we're trying to figure out. So now we need to bounce over and take a look at what we've got on the chipset. And answering the chipset generically, it helps when we can answer specifically with a motherboard. That's kind of what we're doing to balance this out. Synergy. Okay, again, PCI Express 3.0. PCI Express configurations. We have a number of 24 PCI Express lanes. Only so many of those can be reallocated. Some of them are fixed. So we have a by 1, by 2, and by 4. Those are our configurations. And the by 4 is typically 2 things. An M.2 NVMe, M.2 NVMe number 2. And then number 2 would also be a PCI Express by 4 slot, which is what's required for the 10 gigabit Ethernet adapter that's in the box, which is pretty cool. I like that. I like the fact it's ASUS, I like the fact that it's ProArt, and I like the fact that it's got the 10 gigabit Ethernet, because based on what we talked about with storage last time, Blackmagic Cloud Store, look it up. It's in the video description from the last video. And now that I've mentioned it again, I'll get it up in this description. But anyway, RJ45 is the future. And there's another technology that depends on 100 gigabit, which is a Mellanox adapter, that is going to require more than a 4-lane slot. That's another storage platform that I'm trying to figure out how I want to present it to you guys. It's a technology called Ultra I/O from Nirad or Nirad. It looks like Nirad, but I bet you they pronounce it Nirad. But anyway, it's Ultra I/O. And that's another technology coming down the pipeline. This stuff with GPU-based RAID, the stuff we've done where we talked about an operating system RAID, which is software, a hybrid BIOS RAID, which is a hardware-software RAID, but it's actually a CPU-based RAID. We're going to be getting away from CPU-based RAID, getting more into a GPU-based RAID, or with, again to reiterate, the Blackmagic Cloud Store device, which will give you 20 terabytes just for one size, bigger and also smaller. But for 20 terabytes in a RAID configuration external that's hooked up through 10 gigabit Ethernet is phenomenal. Now, that's great for video. However, for audio, you're going to want that stuff local. I don't know how well those instruments are going to stream even through 10 gigabit Ethernet. Now, if you're looking at the hybrid I/O, which is the Nirad configuration, you're looking at something that is in a 4-unit rack server times 4 that takes up 16 units to accomplish what that works. But we're not talking about terabytes of storage. We're talking about petabytes of storage. So it's a whole different animal, but it's coming online. And if it's going to be available for the server, it's going to be available for the workstation, which means it's going to be available for anything else that needs access to it. its potential storage, and that's what we need. Okay, now that we've looked at this generically, let's look at this specifically, how this looks on the motherboard. So we need to look at the manual. Okay, first thing we'll do is go look for specifications. There's 3 things I like to look in a chart, and depending on who it is, number 1, I like to look at a diagram. As you can see, we don't have it. Number 2, we have a specification summary, which is good. Also, number 3, which gives us 4, is we've had connectors with shared bandwidth. I appreciate that. The other item would be the motherboard layout. Yep, right there. So that would be our 4th item, which really helps. So let's go look at the motherboard layout first. And that puts us on 1.2, which is actually page 16. And we have 3 slots. PCI Express plus 16_1, 2, and 3, M.2_1, and M.2_2. That means we have the first 2 slots to the CPU, the first M.2 to the CPU. How's that going to work? We've only got 16 lanes. So we're going to have to go back and look and check how that works in the specifications. Things are not always as they appear because, to reiterate, when you have shared resources, you have a different allocation of those resources, and there's give and take. Some things can be reallocated based on what's plugged in, and some cannot, that are hardwired. For example, like you've got 4 PCI Express lanes. Intel uses a different name, but you've got 4 lanes, whatever you want to call them, that tie the chipset to the CPU. So anything that's in the chipset, no matter how those 24 lanes are allocated, they tell us that we have, they go through 4 lanes to get connected back to the CPU. Kind of a bottleneck, but it depends on how you're using it. So let's look at the specifications, see what it can tell us. I always like to look for information in more than one place. Contents page, this is on page 3, so we'll look at the specification summary, which puts us on page 6. And from the top down, okay, we're looking at a 10th generation Z490 chipset, and you can get DDR4 3200, which is what I would probably focus on, but get whichever one gives you the best bang for the buck and put in the memory that you need. And if we're balancing this for video based on the formula, which is number 1, CPU from Adobe, number 1, the CPU core count times 4 equals the RAM. So if you've got 10 cores, 40 gigs of RAM, you get to where you want to go. I'd say 64 gigs. And then, of course, your CPU core count equals your video RAM. Based on the GPU you've got, well, you can do the math, see where that works out. But that's for the balance, and that's a starting point for Adobe. Now, based on what I know with what all Adobe is doing, my preference is with Blackmagic DaVinci Resolve, especially version 18. It's going to blow the doors off of everything else. And with what they've announced with the new, I got to tell you about it again, Blackmagic Cloud Store, which is a little device for external storage that looks like the box they used to do their external GPU in. Cloud storage, NVMe RAID 5. Wicked, wicked. 20 terabytes. Unit below that, I believe, is, well, anyway, less expensive. There's units above that that are a lot more expensive. But the 20 terabytes keep sticking in my mind. That's the one I want to look at. So let's look at our resources, how this plays out. We know what we need. Let's see what we've got, where it goes. HDMI, I mentioned Thunderbolt. So we're going to need to look at the I/O connector. That would be image number 5. And we should have had something on there for that. Yeah, right there, a DisplayPort adapter cable. I'll come back to it. Okay, with a 10th generation processor, we have 2 PCI Express 3.0 by 16 slots. Okay, they're by 16 mechanically. The primary slot by itself is by 16. In the dual mode, then they both become by 8 electrically. Or you get the other formats. And if you'll notice, right here we get a by 8 plus by 4 plus by 4 and 0. Wow. So that tells me if we were to put a quad adapter in this motherboard, we would be able to see 2 drives either in the 3rd and 4th position based on by 8 right here for the first one, or based on the second configuration, same thing again, in the 3rd and 4th position. So that simple question that requires a lot of information on the Z490 chipset, can you do it? Well, yes, no, and maybe. It depends on the implementation of the chipset on a motherboard. Based on this implementation on this particular motherboard, you're only going to see 2 drives, and there's another document I can show you that will list this kind of information that'll tell you that. But sometimes I think that information is like this. It's a bit overwhelming, even to me, and I know how to do this. I do this, I could do it in my sleep. I find it fascinating that we can do it. But as it relates to these kind of chipsets, I like to relate based on what I know how this works with a high-end desktop like I'm looking at here, which is the Gigabyte TRX40 Designare, which I now say leap over this and build a workstation because of what you get for what the processor is going to do, what the motherboard is going to do with the chipset that you get in that configuration. Blows the doors off of this. This was a good deal or a good value a couple of years ago, but now the workstation's the better deal. But we're not looking at a workstation. We're looking at building a new computer, and we're trying to figure out our resource allocations. Okay, now, that's through the processor. Looking at this through the chipset, what do we have? Through the Z490 chipset, one PCI Express 3.0 by 16 slot, mechanically. Electrically, it is by 4. And then it says there are two PCI Express 3.0 by 1 slots. Curious? I'm wondering if there may be some shared resources. And here's where things get interesting. We have 2 stars for that slot. Wow. And this says supports PCI Express bifurcation for RAID on the CPU function. Yeah, based on how that's going to work, it's going to see 2 drives on a card in position 3 and 4. Okay, if we've got shared resources on slot number 3 for by 4 mode with Thunderbolt 3, then that's not a both, that's an either or. Would you rather have Thunderbolt 3 or would you rather have 10 gigabit Ethernet? That's nuts. For me, that's a deal killer. You should be able to have both, but because of resource allocations, I would say if I had to choose, if I could choose, to eliminate the SATA ports. Because remember, as somebody else commented, I didn't understand why I lost 2 SATA ports. Again, shared resources. You can't have everything. Just because all those connectors are there, all those connectors are not all wired to be live at the same time because of shared resources. When you get exclusive dedicated resources, then everything works all the time on most situations. And there are some motherboards that use U2 that I don't want to get into that are an either or situation. But for the most part, dedicated resources are dedicated. However, with this, we don't have enough stuff to go around. And if I have to choose between Thunderbolt 3 and a 10 gigabit Ethernet, I don't like that. I don't like that at all. That's a real bummer. But I'm not done yet, because I'm always interested if there's some way to make something work. Let's see what else we've got, because I need to look at the M.2 connectors. Okay, 2 M.2 connectors and 6 SATA ports, and all that is through the chipset. Wow. Which makes sense, because M.2_1, we would have to have 20 PCI Express lanes. We don't on this chipset, so that's all through the chipset, not through the CPU. So to reiterate, M.2_1 and M.2_2, we have a star and a 2 star. Those are through the chipset. And then we have 6 SATA ports. And I wonder if we lose any SATA ports. Okay, here we go. M.2_1 is operating in SATA mode, then SATA 6 G_2 will be disabled. And the 2 stars, M.2_2, runs at PCI Express 3.0 by 2 by default. In other words, you're not using 4 PCI Express lanes. By default, it's only using 2 lanes. So the potential of a drive that could be, say, 3,500 megabytes would be half of that, which is what, about 1,750. We had that when we were going from PCI Express 2 to PCI Express 3, and that goes back, what, 6 years, whatever? No, I'm not a fan of that either. So that's a bummer. So when M.2_2 runs at PCI Express 3.0 by 4, or is populated by H10, SATA 6G_56 will be disabled. So, wow. Well, M.2_1 should be running in PCI Express M.2 NVMe. So you'll still have that SATA 6G_2. And M.2_2 should be 4 lanes. So you'll have to accept the fact that you're going to lose SATA 6G_56. No, not a fan of that at all. Now, on board the motherboard, we've got Ethernet. I believe that's 2.5 gigabit. But at any rate, and then all those USB ports. I appreciate all these USB ports. We still have very much a need for USB 2. And anyone that does liquid cooling understands you've got to have one of those USB 2 headers internally. And you've got to have an internal USB 2 header for other stuff. So all these SATA ports, I wish those would reallocate those resources to something that, from my opinion, are more exclusive, more desirable. I mean, how many USB devices do you plug in? I'll plug in a lot more M.2 drives and a lot more SATA drives than I ever will be having USB whatever plugged in at the same time, because it's just, USB has overhead. I would rather have USB-C ports. I don't need a gazillion USB 3 ports. 2 would be fine, but I digress. So for me, that's a dislike. Let's go now and take a look at the shared bandwidth, which is on page 11. This is the one that's the real eye-opener. PCI Express was 16_1, 2, and 3. And we see the chipset and M.2_1 and M.2_2, which are through the chipset. And there's the PCI Express by 1_1 and PCI Express by 1_2. So the question will get asked, what would we plug in to one of those by 1 slots? A capture card that would do 1080 would be acceptable for that. Or if you want to add more USB ports that I've just kind of bummed about, you could do it with that. But something like that. And remember, your capture cards, even the capture cards that require 4 lanes, are probably PCI Express 2. So they're not really a resource hog, but some of them require 4 lanes, some of them require 1 lane, like the 1080, and some of them, like the Blackmagic cards, require an 8-lane slot. It depends on what you're doing. Depends on the capture card. But that's one use for those. So down below, the configuration, PCI Express was 16_1 and 2. To reiterate, okay, PCI Express was 16_1 is about 16 slot mechanically and electrically when used by itself. However, when the 2 slots _1 and _2 are used simultaneously, they both are then, because they are shared resources, each is about 8 slot. And because those together are each about 8 slot, you can't put a quad card in there because you got to have 16 lanes. So those 16 lanes have to stay to that 16 lane slot. But based on what we see, the way the BIOS is configured, and ASUS has a document that will confirm that information that I'll share with you, but I don't want to get into here because I think it's confusing. Just suffice to say, it looks like we're only going to be able to see 2 drives out of 4, even though there should be 16 lanes there. It's because of the way the resources on that slot are allocated, which are specific to the configuration for that motherboard that's using that chipset. So generically one thing, specifically something else. That's why I wanted to show both these. And you can never make a blanket statement about a motherboard. We have to look at every one of them because every one of them is different. And I find those kind of stats fascinating. I hope you do too. Not always to our best, highest and best use we want, but it is what it is. Okay, and then going down to the M.2_1, that is 4 lanes. And M.2_2 by default is 2 lanes. But to reiterate, you can set it in 4 lanes, so that'll be a BIOS setting, which is what you want to do. And PCI Express was 16_3 and Thunderbolt in that configuration. PCI Express was 16_3, which is where you'd put the RJ45 for the 10 gigabit Ethernet. That's a 4-lane slot. However, if you're going to use Thunderbolt, you can't have both. And that's a real, that's a bummer. Now, if you're looking at that motherboard because you think it's pretty, I agree it's pretty, but it's not as functional as it needs to be. But this is the way that motherboard is allocated. I want to take a look in the manual because I'm always looking to for the BIOS, because I'm always looking for consistency. And because this is ASUS, I'll do a search for the word hyper threading, and I should see, there it is, hyper M.2 by 16. This item allows you to set different configurations for the hyper M.2 by 16 card. The configurations may differ between motherboards. No kidding, Sherlock. Please refer to your motherboard's user manual for more information on the configurations. And all this shows, and this is a generic manual that's available for the BIOS for this motherboard, is that yes, you can set that for an M.2 by 16. It's either enabled or disabled. But based on the other manual, now this time I did a search in the primary motherboard manual about the Hyper M.2 by 16. And it says, please refer to the following tables for the recommended VGA configuration and Hyper M.2 by 16 configuration. And again, we're looking at PCI Express by 16_1, 2, and 3. And we're now on page 22, recommended VGA configuration. _1 by 16, primary slot, _2, 1 and 2 by 8, and then of course _3 is by 4. If you were to say, where would I put the GPU? And if we're going on down to the Hyper M.2 by 16 card, which is a quad card, remember we need 16 lanes. This reinforces and reaffirms what we've already seen. PCI Express by 16 _1 is by 8 plus 4 by 4, or PCI Express 3.0 by 16_2 can be 4 by 4. So either one of those slots, you're only going to see 2 drives. It stands to reason in the second slot you see 2 drives, but I'm really surprised in the primary slot they cannot do a full bifurcation. They've got a by 8 and then a by 4 by 4, which means you'll see drives 3 and 4. And then you have to look in that other chart that I'll have a link up that talks about how this plays out in all their motherboards, which again, to reiterate, I think it's confusing. Well, I'm not a fan of that, but I can't believe some of these things you guys put up with. Here it talks about when using 2 drives, PCI Express was 16_2 and PCI Express was 16_1. And then it talks about using 3 drives, PCI Express was 16_2 being disabled. Suggest using the internal VGA. Well, that's not a good idea if this is about rendering video, because rendering video uses the GPU. Wow. So there's things you can do. So that's pretty much it. So there are things that you can do, but as it shows you, not a good idea. So I would rather give you the short answer and say no, but then someone says, well, what about and what if? So the what if is technically, yes, you can, but a quad card with 2 drives is not a quad card with 4 drives. It's not a good use of PCI Express resources. So again, to reiterate, asking the question about the chipset, we need to take a look at the motherboard and see how that resource is allocated. Otherwise, it's a definite maybe. And for this specific motherboard, what do I think of it? On the surface, the 10 gigabit Ethernet, that got me excited. And the fact that it had Thunderbolt 3 got me excited. I'm curious to see how they did it. They don't. It's either or. It's not both. And I don't like having to make that choice, that decision. That's not good use of resources. Now, the last thing I want us to look at right quick is the rear I/O connection, because this is about Thunderbolt. There's HDMI, and these 2 ports are display port in ports for Thunderbolt 3. So yes, you can ingest video from an external GPU based on these 2 connectors on that motherboard. The motherboard had lots of possibilities, but it's all dressed up and not quite ready for the party. So I want to thank you guys for watching. This is BuildOrBuy. My name is Gil Boyd. We look forward to seeing you next video. Welcome. We're out.